Okay guys, in this video we're going to be talking about the average rate of change formula. So what is the purpose? What is the average rate of change formula? So the purpose is to find the rate of change for any function f of x in the interval a to b. So if they give you a function and they give you an interval from this starting point to this ending point, you can figure out what is the rate of change. Now rate of change, that word, the average rate of change, is just a fancy way of saying slope. And you guys have already done slope, finding the slope between 2 points. If you remember this formula, you've already done it. So the slope formula is the following. To find the slope between any 2 points is m is equal to y2 minus y1 divided by x2 minus x1, which means you just subtract the y's, subtract the x's in the same order, and then you get your slope when you put one over the other. The average rate of change formula looks very, very similar to that. So this is the rate of change formula by comparison. So it's function evaluated at b minus function evaluated at a all over b minus a, which looks very similar to that because guess what? It's the same thing. So how is it different and how is it the same? So the average rate of change, like I said, is just a fancy way of saying slope, but it's generalized for any function, not just a line. So basically, if they give you any function at all, you could find the rate of change for that function. So let's do this little quick example. So I drew this function, right? So basically just the graph of a function. And I'm trying to find the rate of change. So the rate of change is just a way of saying slope, right? So how much do I have to go from left to right? It's always left to right like a book. How much do I have to go down and over to get from this point to that point? So that is the rate of change, the average rate of change. And it's called the average rate of change because if you look at it, the line's not straight. So we can't say that it's the slope because it's not really, because the slope changes. So it's the rate of change. So how much do we go down from this point to that point? We got to go down 1, 2, 3, 4. So this will be a minus 4. And we got to go to the right 1, 2, 3. So this will be a positive 3. So the slope, or I should say the average rate of change of this would be negative 4 over 3. Done. How do we find the average rate of change from this point to this point? Again, the interval changes. Slope is rise over run. So how much do I have to go up? How much do I have to go over? So if you actually count this example, we have to go up 1, 2, 3, 4, 5, 6, 7, and then we have to go over 1, 2 squares. So the slope, or the rate of change, would be 7 over 2. Okay, now the difference between the average rate of change and the actual slope is that slope is a line. But like I said, the process of finding the average rate of change and the slope is the same. To get from this point to this point, you have to go down and over, same as the other example. To get from this point to this point, you have to go up and over, same as the other example. So from this point to this point, you got to go down 4, 1, 2, 3, 4, over 1, 2, 3. So this is again negative 4 over 3. And then this one, same deal. We got to go up 7, 1, 2, 3, 4, 5, 6, 7, over 2, 1, 2. So the slope is positive 7 because we went up over 2. So slope for a line, average rate of change for a squiggly line, you get them the same method. So it's the exact same thing. Now, the only difference is for the average rate of change formula, they actually want you to use the formula to be able to find the average rate of change for a function when they don't give you the graph. So when they don't give you the graph, how do we do that? So for example number 1, let's concentrate on this one first. Example number 1, it says find the average rate of change of the function f of x is equal to 2x minus 1 over the domain interval 0, 1. Now I'm going to go ahead and just write somewhere on the side. If I have the formula y equals 2x minus 1, and I were to ask you what is the slope, right, the rate of change, the slope is the number in front of the x. So for this line, y equals mx plus b, right, the m, which is the slope or the rate of change, is equal to 2, no matter what. So we could have answered that question in the beginning without doing any work, but let's do it by showing some work. So even though we know the answer. So what is the average rate of change of this function f of x equals 2x minus 1 over the domain interval 0 to 1? So first thing we need to do is figure out what is the formula. So if you remember, this formula for the rate of change is f of b minus f of a divided by b minus a. So we got to figure out one thing, and then we got to figure out this thing, then we got to figure out this and that, and then we got to plug it in. So the easiest thing to figure out is the interval 0, 1. So a is equal to 0 because that's the beginning starting point, and then b is equal to 1 because that is where we want to end. So we have two things already. Then we want to figure out, okay, what is f of a? So f of a means what do we get when we plug in a? So basically what that means is what do we get when we plug in 0? So when we plug in 0 into the function, we're going to be left with 2, right? This is the function up here, multiplied by 0 minus 1. So f of a is actually equal to negative 1. So we have 3 things that we need to use the formula. Now we just need to find f of b, and then we can use the formula. So f of b is what do we get when we plug in b into the function, which in this case is equal to 1. So when we plug in 1 into the function, which again was 2 parentheses x minus 1, which we're going to replace that x with a 1, it's going to be giving you 2 minus 1, which is equal to positive 1. So we have f of a, we have f of b, and then we have b and a. We basically have everything we need to plug it into the formula. So if I circle f of b, that is the 1 right there that we just found. If I circle f of a, that is the negative 1 that we just found, right? And then the b and the a, we already had it from before. So that is the beginning and the ending point that's given to you with the formula. So if we plug everything into the formula, we're going to be getting this. So I'm going to just forget about this for a minute. Let's concentrate up here. So f of b was 1 minus f of a, which was negative 1, and then put that over b minus a, which is 1 minus 0. If we simplify this, this is 1 minus minus 1, which is a plus, right? Because 2 negatives make a positive. So that's just going to give you 2 over 1, which, oh wait, we already knew that, right? It was going to be 2 from the other paper that I showed you. So the rate of change, or the slope for this line, right, y equals mx plus b, is going to be 2 no matter what. But we did it with the formula. So this gives you 2 over 1. Now, why do we have to use the formula? Well, we don't have to use the formula if they give you a line, but they're not going to give you a line every time. They're going to give you something different, and they're going to switch it up on you. So for example number 2, this time we have this function. So what is the rate of change of x minus 1 squared minus 4, which is this function, over the domain 1 to 3? So same process. So first of all, we need to figure out, okay, this is the formula for rate of change. So f of x, or sorry, m is equal to f of b minus f of a, and then put it all over b minus a. Now, we don't know what those things are yet, so we're going to find those things out down here somewhere, like we did in another problem. So first thing we need to figure out is what is a and what is b. And we look at the interval, a is equal to 1, b is equal to 3. So a equals 1, b is equal to 3. Done. Then we got to figure out what is the function evaluated at a, so what is f of a. So when I plug in a into the function, meaning when I plug in 1 into the function, what do we get? So the function's over here, right? X minus 1 squared minus 4. So we're going to plug in 1. It's going to be 1 minus 1 squared minus 4. And that's going to give me 0 squared minus 4. And that's going to simplify to negative 4. So my first answer, f of a is equal to negative 4. All right, now let's find f of b. F of b is what do I get when I plug in b, which in this case is 3. So what do I get when I plug in 3? If I go back to the original function, x is now going to be equal to 3. So 3 minus 1 squared minus 4, right, from that function right up there at the beginning of the problem. 3 minus 1 will give me 2. You square that, subtract 4. That gives me 4 minus 4, which gives me a total of 0. So we have everything we need to plug it into the formula. If you remember f of b, we figured that out just now, right? F of b was equal to 0. If you remember also f of a, we just figured that out also. F of a was equal to negative 4. And then b minus a, well, we know a is 1 and b is 3. So all we got to do now is plug it in. So I'm going to go back using these values to plug it into my original function. So I'm going to have f of b, which is 0, minus f of a, which is negative 4, and then put it all over b minus a, which is 3 minus 1. When we simplify that, we get 4 divided by 2, which again is equal to 2. So the rate of change over this interval for that function, 1 to 3, is equal to 2. And I did that, or we did that, without even having to graph anything. So this is basically a way for finding the rate of change without having to graph it, without having to count rise over run, because they don't give you the function, right? I mean, sorry, they don't give you the graph, they just give you the function. So one more and then we're done, just in case it's not clear. This example, we actually have more than one variable, so more than one x. in there. So in case you have more than one variable, make sure you're careful, because that means you actually have to plug it in more than once. So in this case, we have negative x squared plus 4x minus 1 as our function. We want to figure out what is the rate of change over the interval 1 to 3. So same process. The rate of change formula is f of b minus f of a, and then put it all over b minus a. We don't know any of those values yet, but we're going to figure them out. So the only thing we do know is the interval is 1 to 3. So a is equal to 1. That's the first initial starting point. And then b is equal to 3. That is where we end. Now we got to figure out, okay, what is f of a, what is f of b? So f of a would be whatever we get when we plug in a, which in this case is whatever we get when we plug in 1. So let's plug in 1, but this time we got to plug it into this function, right? So be careful. This is going to give you negative 1 squared plus 4 times 1, right? And then you subtract 1 after that. So this x appears more than once, so be careful when you're plugging stuff in. If it appears more than once, then that means you got to plug it in more than once. So be careful, depending on your function. So this is going to give me something that I have to simplify. First, I have to square this, and then I have to multiply by the negative 1. So be careful, make sure you're sure of your order of operations. So this is going to give you a negative 1 on the front, right, which was already there. And then multiplied by that positive 1. And then we got to add 4 to that, because 4 times 1 is 4. And then we got to subtract 1 from that. So that gives me negative 1 plus 4 minus 1, which gives you a total of positive 2. Okay, so we figured one of them out, f of a. Now we got to do it again. Let's figure out what f of b is. So f of b is whatever we get when we plug in b, which in this case is whatever we get when we plug in 3. So we plug it into that function again. It's going to be negative something squared plus 4 times something minus 1. So we replace that. All those parentheses is where the x used to be. But now we're going to replace that x with the value that we want, which in this case would be 3. So plug in 3 there, plug in 3 there, because that's b. Again, we got to square it first, and then put the negative in the front. So 3 squared is 9, so that's going to give me negative 9, plus 4 times 3 is 12, minus 1. Remember your order of operations. First you square, then you multiply. So this is going to give me 3. 3 minus 1 would give me a total of 2. So there we go. F of b and f of a happen to be the same thing. In this case, f of b happens to be 2. So I'm going to be replacing that with a 2 way up there. And then f of a, for this example, happens to be 2 also. So I'm going to be replacing that with a 2. And then b and a, they already gave it to us in the problem. B is 3, a is 1. So we're going to plug it in. 2 minus 2 divided by b minus a, which is 3 minus 1. We get 0 over 2, and 0 divided by anything is 0, so the slope in this case would be 0. That means that the line is, or the function would be remaining flat. Okay, I hope this video was helpful. See you guys on the next one.